All right, here we go. So we have to find the inverse of that function. The first thing I would do was convert that to a y, and then to find inverses, what do we have to do? Switch what? The y and the x. So I'm going to say x equals 3 plus 5y over 2 plus 5y. Okay? I have to get y by itself now. All right? So we've got a little bit of algebra to get there. I'm going to start by taking this and multiplying it onto the other side. Equals 3 plus 5y. What do you think we should do with that x? Distribute it. So 2x plus 5xy equals 3 plus 5y. Alright, I am going to choose to move everything with a y to the left and everything else to the right. Okay? So I'm keeping the 5xy. How would I move this 5y? Subtract it. And then I'm keeping the 3. How do we move the 2x? Subtract it. All right. And then what can I factor out here? A y. We don't want to take the 5 out because we're trying to isolate y, right? So we're going to just leave the 5 in there. So 5 minus 5x, or 5x minus 5 equals 3 minus 2x. And then I'm going to divide by that. So 3 minus 2x over 5x minus 5. Which does not look... Oh, wait. It looks like this one, right? Yeah. Was that the one that it came up correct as?
Yes.
All right, because Miss Dudley was questioning that one, so I didn't look at it very carefully when... All right, we good with 31? Yeah. Okay. 32. So, when we see that variable in the exponent, what should we do to both sides? No. We just learned it. We log both sides, right? You have to know this by what? Wednesday, right? Equals log of 29. You have to know what to do. All right, where's this exponent going to end up? In the front. So you've got x log of 3.07 equals log of 29. You're going to have your calculator open for this, okay? For this part of the test at least. So I'm going to take this. How do I get this log to the other side? I heard somebody say it. We got to divide it, right? Okay, everybody in your calculator right now, try this, okay? I don't have mine up, but make sure that I would do a control divide so it takes care of your parentheses issues, okay? So everybody try it, type it in. Don't call out an answer yet. Wait till I ask for one. So we give everybody a chance. All right, what did we get?
3.002.
0, 002? Yeah. Okay, great. You did something wrong. Did you close parentheses? I don't know what happened. All right. So on this one right here, when I'm checking for, when I have one log on one side, that is when we do the log loop. Okay, so what's your base? 4. And then we loop this around. What's the exponent you're going to use? 2 equals 3x plus 10. Okay. What's 4 squared? 16 equals 3x plus 10. I'm going to do what with this 16 to get it moved over? Or sorry, what with the 10 to move it over? Subtract, what do you end up with? 6, so x equals 2. If I put a 2 in here, is there any way it's going to go negative? No, that you need to make sure you're checking for your extraneous. Okay? Okay. We good with 33? Alright. Let's take a look at 34. We need to use them to change a base formula. So basically, there's 2 ways I could possibly do this. They could write the answers log of 12 divided by log of 5, and that's a good answer choice. Okay? It could also be a decimal point. So what you need to do is try that in your calculator. Do you really need to do this in your calculator?
No.
Can't you just hit your log button and do log base 5 of 12? Okay, so either way, put it in. Everybody practice it. I'm going to give you like 30 seconds to put it in. Don't call out the answer yet.
What day was Friday?
What day was Friday?
The 8th.
Was it the 8th?
I don't know.
Yeah, I think it was the 9th.
Friday was the 9th. Okay, what do we get for the number?
1.544.
544.
Yeah.
All right, everybody good with 34? All right, 35. We're going to use properties of logs to expand. What does division turn into? Look at your answers. Has to be that one, right? Okay. There's a lot of stuff in there to confuse you, but let's do the whole thing and make sure, just in case it isn't like that where it's obvious. Okay, it might not be obvious on the test. So we've got log base 7 of x cubed minus log base 7 of x to the 1/4. And then where do these exponents go?
Front.
In the front. So 3 log base 7 of x minus 1/4 log base 7 of x. So it's definitely answer choice, or the last one. Okay. We have to classify the system. The best way to do this is to solve for y. Okay? So I'm going to take and move the 2x to the other side by doing what? Good. So negative 6y equals 2x plus 8. And then what do I do to move the 6? Divide it. Okay, so if I divide by negative 6, y equals negative 1/3 x minus what?
Would you switch the 2x to negative?
Yes, I would. Thank you. Okay, so it's going to go positive. All right, what's the 8/6 reduced to, guys? 4 over 3. Okay, so that's my first equation. Now I'm going to do this equation. I've got to move the 4x to the other side. How do we move the 4x to the other side? Subtract it. Plus 16. And then what are we going to do with the negative 12? Divide it. So you've got y equals, that's going to reduce to 1/3 x minus what? 4 over 3. So when the equations are exactly the same, it is consistent and dependent. That means we have the same equation. Consistent and independent is basically they're not the same, right? They cross somehow. Inconsistent, they have the same slope and different y-intercepts. And this last answer is nonsense. Okay. This one just has to have different slope on this one. Okay, it doesn't matter where their y-intercepts are. Alright, we good with 36? Alright, the other side of that is how many solutions does it have, and we can get it from the same thing by solving for y. Okay, or you just start solving it, but I'm going to go ahead and solve for y. What am I going to do to move this 2x to the other side? Good, so 10y equals negative 2x plus 17, and then what are we going to do to move the 10? Divide it, so negative 2 over negative 10x plus 17 over negative 10. So I'm seeing 1/5 x plus 17, or minus 17 tenths. Minus 17 tenths. Okay, and then I gotta solve this one here. How do I move the x to the other side? Subtract it, so I have y equals negative x plus 5. What do you notice about these slopes? They're different. If the slopes are different, that means it is consistent and independent, meaning there's only one solution if I graph that. Two solutions never happens with what we're doing. Okay, it would have to have a parabola. All right. No solutions is when they come out to be parallel. So same slope, different y-intercept. Okay. And and then the infinite is when you have the same exact equation. Okay? You could put anything in there and it would come out the same. Alright, let's talk about 38. Which of the following best describes the transformation of the graph below compared to this graph here? Okay? So here's what I would probably do. I would probably examine the vertex. What is the vertex of this graph? 6, -2. And 6 is a right movement, correct? And 2 is a down movement. So 6 units to the right, 2 units up. That doesn't work. We know it's got to go 6 units to the right. So it's got to be the third one, right? 2 units down. All right. So from here on, there's no calculator. Okay. So these would actually be the first ones on the test. Okay. We're going to put these first, and then we'll let you open up your calculator. We probably won't put a time limit on it, but we'll probably try to encourage you to be done with it probably in 15-20 minutes. Okay. Because you want to make sure you're using the rest of the time for the bigger portion of the test. All right. 1 0 of the polynomial is this. What are the other zeros of the polynomial? I want to make sure you can do this by hand, and I know that you know how to type it into your calculator and find the zeros on the graph, right? That's why we put this on the calculator closed section, right? So, probably where I would go with this is synthetic division and get it factored out, okay? So, what is going to go in this box? The 3, and it's going to be the 3, because when it's x equals, you keep the sign. When it's which is the opposite of that, right? I just I set it equal 0. It's switch the sign, okay? But I guarantee your -3 answer is probably located in there somewhere, okay? All right, what are my coefficients? Good. Nothing missing, so no tricks. We're going to drop the 4. What's 3 times 4? 12. 12 plus -11. 1 times 3. Plus -6. -3 times -3. Remainder 0, which is what we were looking for, right? So that means this piece here turned out to be 4x squared plus 1x minus 3. I have a couple of ways I could do this. I could go through and do my P's and my Q's, or I could guess one of the, I could try to figure out which one of these would make it equal to 0, or I factor it, right? So I'm going to go ahead and use my magic X. So 2 numbers that multiply to -12 and add to 1.
4 -3.
Good. Do we need a box?
Yes.
Why do we need the box, everybody?
Because it has a...
Good. All right, top left-hand corner is 4x squared. Bottom right's -3. We've got 4x and -3x. All right, what times what is 4? Is 2 times 2 going to work this time? No, so what's my other choice? 4 and 1. Where's my 4 got to go? On the side. How many times does 4x divide 4? How many times does 1 divide -3x? And then check it. -3 times 1 is -3. So we've got, oh, I lost an x here, didn't I? So we've got x plus 1. I'm just going to set them equal to 0. And 4x minus 3 equal to 0. So x equals -1. Is -1 one of our choices here? Looks like it. C, right? And then we've got 4x equals 3. X equals 3 over 4 is one of our other. Is that one of our choices? Yep. So this is a multiple response problem, right? I need to choose both C and E. Okay. Remember, if I give you a multiple response on the test, no spaces, no commas. Okay. All right, we good with 39? All right. Number 40, it says we're supposed to compare. So, let's talk about the movement left and right first. So I know it's in X movement, so it has to go left or right. It's really moving in the +5 direction, right? So that would be the vertex point on there. So is positive to the left or to the right? Right. So we're looking at right 5, so we know that it's E. What does the 3 in front do? Does it stretch it or shrink it?
Shrink it.
think it stretches it.
That's just last from the negative.
All right, and then what does the negative in front do? It does a reflection in the x or the y?
X.
X. Okay, everybody type in BCE. Make sure we did that right. I'm pretty sure it's a stretch. Did that turn out right? Checking it in a haiku? Yeah? Okay. Alright. Write an equation of the function whose graph has this shape, but has moved 4 units to the right and 2 units up. Basically, isn't that the vertex? 4, 2. So I have to get it back into this skeleton of this equation, right? Squared plus or minus something, right? So, what happens when we go in or out of parentheses? Opposite sign. So I've got to go -4, and then outside the parentheses we keep the sign. So it's looking like the third one.
Yep.
All right. I know the pictures are kind of tough to see. It looks like we've got a hole here, right? And here. Is there a hole on either one of those? I can't tell. Look at the computer, might be easier to look at. I don't know. Is there a hole on one of those? Oh, right here, isn't it? Is that right? Just on B and D? Just on C, just those last two?
There's just one on B.
Is there one here? Is it right where I have it? Yeah, it's just really tiny.
Yeah.
Okay. All right, so we've got our holes. It looks like our holes, look like they're all in the same place, don't they? So it looks like it's going to be based off of asymptotes for the most part. So we would know to eliminate this first one if there isn't a hole, right? Or if there is a hole. All right, so let's go ahead and do our good old magic X. So 2 numbers that multiply to -8 and add to 2. 4, -2. Okay, so I've got x plus 4 times x minus 2. All right, and then the other magic X would be 2 numbers that multiply to -12 and add to 1. 4, -3. So we've got x plus 4 times x minus 3. All right, what happens?
X plus 4 and X.
And when it cancels, what do we call that?
Hole.
A hole. Okay, and so our hole should be at -4, right? We flipped the
Yes.
sign. Are all those holes at -4? Yes, unfortunately. So that one's out. We've at least eliminated one. Okay. The next thing I would look at is where is my vertical asymptote? Okay. My vertical asymptote, remember, is what's left in the denominator set it equal to 0. So where's the vertical asymptote? 3, which is the only one that has a vertical asymptote at 3. Is this one at 3? No, is this one at 3? -3, is it at 3? Is this one at 3?
Yes.
Yep, it's got to be that one. All right, we go to 42. All right, looking at this one here, which pair of equations best describes the graph below? Okay, do you see how all the lines are actually well, they're almost all the same in those, right? This one looks different, but all the rest of them seem to have the same. Oh no, almost. Looks like some of the lines are changed. So let's figure out the lines, okay? What's the y-intercept on this line right here? 3. Okay, so we know it's a +3. What's the slope?
1, 2.
Up 1/2, which is really the same as saying x over 2, isn't it? All right, so if I don't have that equation, I'm crossing it out, so that one's gone. Okay, all the other 3 have that. Also looking at that, it's an open circle, isn't it?
Yeah.
So it's got to be less than, strictly less than 2. Look at our answers. Is this one still in?
Nope.
Nope. Is this one still in?
Yeah.
It has to be less than 2, right?
No.
Is that one less than 2?
No.
Nope. It's got to be this third one. Let's verify that this is right, though. Okay, just to double check our work. It looks like we definitely have a slope of what?
1, 2. 1, 2.
Down to, right, I should have drawn it under there. Down 2 over 1?
Yeah.
Is that right? Okay, so is my slope correct in this equation? Yeah? Okay, let's look at the y-intercept just to verify it. So I'm going to keep going up 2 over 1, up to... Did I get the same y... Is the y-intercept correct? Yeah, okay. And then it said it had a closed dot, and we were to the right side of it, so greater than 2. So do we agree with that statement? Yeah, I would. What's wrong?
Why is it less than 2?
Why is it less than 2? Because this graph is only valid to the left of it. Do you see how that arrow makes a nice little inequality sign?
Oh, okay.
Okay, that's a good way to remember it. Okay, let's take a look at 44. Again, it looks like, let's see, are any of the equations different in any way? It's the first thing I look at. Looks like they're all the same, aren't they? So it looks like it's going to be mostly based on the inequality sign. So I do need to figure out which equation is which, though, right? So let's see. Is that scaled by? I can't see it this far. You guys can see it on your computers better than I can, probably. Is it scaled in ones or twos? Ones. So this is 1, 2, between 2 and 3. So we have to find the y-intercept. So I'm trying to figure out which line is which. So let's try this one, see what happens. So negative or 4y less than 5x plus 10. So y, is this what we said it was between 2 and 3? 5/4 isn't between 2 and 3, is it? Oh wait, between 2 and 3 for the y-intercept. Sorry, not 5/4. We need to look at this. 10/4 is between 2 and 3, isn't it? Because 4 goes in there twice with 2 left over. So would we agree that that line right there is the second line? Okay, so we know that that second line needs to be dashed. Look at all of the inequalities. Which one do we get to get rid of? The fourth one's gone, right? Because it's not dashed. All right, since we're working on that line, let's test our favorite point. What's our favorite point to test?
0.
0, 0. So I'm going to test 0, 0 into here. So I put 0 in for x, 0 in for y, I get 0 less than 10. Is that true or false? True. So my arrows should be pointing towards the 0, 0. Is that where the shading is going? No, we need it to be false, right? So this one's out. Are the other two going to be okay?
Yes.
Yeah, because there's 0 greater than 10 on both of these. So they're both false. All right, so now we need to look at the other inequality. Are they both solids on the other inequality? Yep, okay, so we can't eliminate based on that. It looks like it's going to be based solely on the true-false, right? So I'm going to still test my favorite point. I'm putting in 0 in for x and 0 in for y. So 0 greater than or equal to negative 39. True or false? True. Okay, so if I pointed my arrows towards 0, 0 from that line, do I want it to be true? I want it to be false, so it's got to be this one. All right. I actually hate those questions, but they're almost always written that way. All right, this is the last one, right?
Yeah.
We got to do a little matching. Okay. So they gave us 6 choices just to confuse us. But we should be able to narrow it down to 2 for each one of them. Okay. Which 2 look cubic? D and C are cubic, right? So I need to figure out, let's see, it looks like, what's going on? What does the 4 do to it?
Up 4.
It makes it go up 4. Which one is going up 4? C. So this one's definitely C. Okay. All right. This one's exponential. Which 2 look exponential? B and E look exponential. Okay. Exponential typically looks like this, doesn't it? What's the negative going to do to it? Flip it the other way. Which one's flipped the other way? B. So this one's B. All right. And then, so that means that we're down to A and F for our radical. It's supposed to shift left, right with this, right? Correct? So my vertex is really where?
Negative 1, 0.
Negative 1, 0. Where's the vertex? Which one has the vertex negative 1, 0? F. So this one's F. And it also, the other clue is it flipped upside down, but they both flipped upside down. Okay? All right, that's it. So at this point, you should have the last 3 homework assignments from last week finished, right? if you were following along. I will come around in about 2 minutes to stamp. You have the rest of the period to work on what you need to work on, and then you should remember, you should be retrying the study guide for the final. Tonight, I would try to redo most of it and then narrow it down to what I really don't know how to do, because you can still ask me a question tomorrow. Okay? When is all the work due?
Wednesday.
No. Tuesday, tomorrow. Not Wednesday. I will not take it on Wednesday. Okay? Yes. Yes, take the pass. Okay? All right, I'll be around in about 2 minutes to start stamping, okay?